Okay, so sample space, we talked a little bit about this yesterday. So the sample space is just the set of all possible outcomes. And the fact that you're dealing with sets, you need to be in set notation. All right, so that means you're going to be dealing with braces, set notation. So your sample space will be written in braces, separated by commas. So there are a whole bunch of ways that you can determine the sample space. If you want to actually show a sample space, you can do tree diagrams, you can list things out. It doesn't really make a difference what you do. Next page, possibly. Okay, so a die and a coin are tossed at the same time. The die is fair, which means it's got 6 faces. A coin is going to have heads and tails. The idea is to draw a tree diagram and then also list the sample space. So in terms of a tree diagram, you're starting from a toss and you've got a heads of a coin or a tails of a coin. Well, after you toss your coin, or maybe at the same time you toss your coin, you roll a die. Well, the die has 6 sides, 2, 3, 4, 5, 6. The tails, again, sometimes it gets all messy, also has 6 sides. So this is your tree diagram. Your sample space is going to look like this. Inside set notation, I can have a heads with a 1, a heads 2, a heads 3, a heads 4, a heads 5, a heads 6, a tail 1, a tail 2, a tail 3, a tail 4, a tail 5, and a tail 6. Notice that there happen to be 12 outcomes. Maybe somewhere you kind of write that out, but that's really just for your own benefit at this point. So your tree diagram is shown and the sample space is shown as well. Well, what's the probability of getting a 6 and a heads? Well, the only time that I see a 6 and a heads is here, right? So the probability of getting a 6 and a heads would be a 1 out of 12 chance. What's the probability of getting an odd number and a tails? I'm going to go for a different color highlighter. Odd number tails. So I can only look for tails. Tails odd, tails odd, tails odd. So there are 3 out of 12 ways to get a tails and an odd number. Then the last question is, what's the probability of getting a heads? They don't specify the number, they just specify the coin. So there are 6 ways out of the 12 to be sure that I get a heads. Don't worry about simplifying anything, just kind of keep them as is. Okay. Next one. Whoopsie, wrong way. Next one, wrong way again. So the students in an 8th grade social studies class were assigned a research paper. The subject of the paper was to be one of these past U.S. presidents: William J. Clinton, George H. Bush, Ronald Reagan, Jimmy Carter, and Richard Nixon. The paper was to focus on one of these 4 specific time periods of the president's life, either their childhood, or their adulthood before becoming president, during their presidency, or after their presidency. What's the total possible number of topics consisting of one president and one specific time period? Well, you can definitely do a tree diagram for this. We know that we have these 5 presidents. So we're going to start from here, and we know we can have either William J. Clinton, we could have George H. Bush, we could have Ronald Reagan, we could have Jimmy Carter, we could have Richard Nixon. From each of these presidents, there are 4 time periods. 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And the time periods, we're going to abbreviate those, which is going to be childhood, let's see, adult before president. So we'll just do adulthood, presidency, or after presidency. So C, A, P, A, P. C, A, P. It definitely gets a little bit messy. C, A, P, A, P, C, A, P, A, P. So just so you realize that you now, if you read all of your branches, you really have a total of 20 outcomes. So then the question, I think I can do a split screen with this too. I think if I can do, let me go to the next page and do a split screen. Nope, go this way and go this way. So the question then says, well, how many of the possible topics include a president's childhood? Well, a president's childhood, there are 5 of those. Childhood, 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 and childhood. I missed it somewhere right here. So for president's childhood, this is A. There are 5 presidents, and there's childhood. There's one of those time periods, so A would be 5/20ths. Bill Clinton, anything about Bill Clinton? Well, there's 4 time periods to do with Bill Clinton, so that's 4 out of 20. A president that's from the 1990s. So hopefully you know the president from the 1990s. We're going to be dealing with Clinton and George H. Bush. So that's 2 presidents, but there's 4 periods per each, which is going to be 8 out of 20. And then childhood or adulthood before becoming president. So childhood or adulthood before becoming president would be 2 categories for each, and then there's 5 of them, so 2 categories for each would give you 10 out of 20. Okay, let me go to the next page and unsplit screen. Alrighty, let's go to full page. Nope. Let me see if I can figure this out. So I want to go to just, okay, oh boy, let's see. If you can tell, I just figured out the whole split screen thing. Okay, got this, got this, got this. Oh, we're missing something here, no? Hold on. Okay, I am missing a slide for some reason on counting principle. Don't know what happened, so I'm going to put this in here. So you should have a slide on counting principle, and basically what it's saying to you is for a sequence of possibilities. You know what, I'm going to pause this for a second. I'm going to get this thing up, and I'm going to come back. So hang tight. Okay, I'm back. Got it. All right. So counting principle. For a sequence of possibilities, the total number of possible outcomes is the product of the number of outcomes for each part of the sequence. Remember, product means you need to multiply. So what happens here is if there are m choices for one event, event A, and n choices for another event, or event B, then the product of those choices, m times n, is going to be the total number of possible outcomes that you can get. So here's an example. Jen has 3 pairs of pants, blue, red, and black. She's got 4 shirts, pink, white, striped, and tan. She's got 2 belts, black and brown. How many different pants, shirt, and belt outfits can she choose from? Well, the shortcut is to say, well, I can multiply all of my choices together, 3 times 4 times 2, and realize there are 24 outcomes. You may or may not want to do a tree diagram to figure it out, but looking for outfits that have red pants. I will show you the tree diagram in case that you feel that you need it. So the idea would be if I were to start off with my pants, which are black and red, sorry, brown, red, and blue, red, and black. Then off of that, in each of them, I would have 4 shirts. And the 4 shirts would be pink, white, striped, tan, pink, white, striped, tan, pink, white, striped, tan, pink, white, striped, tan. And then off of that, I would have my belts. And then hopefully you can just kind of figure it out from here. But basically, we've got a black and a brown that goes all the way down. So how many outfits could she choose that would have red pants? Well, red pants is this middle piece right here. So red pants is this middle piece right here. And at the end of this branch, we know we're going to have basically 8 out of 24 ways to have a red pants outfit. So red pants would be 8 out of 24. To have an outfit that includes a belt, well, every single outfit includes a belt. So there's 24 out of 24 ways, or one whole. Every single outfit's going to have a belt. Black shirt, well, there aren't any black shirts anyway. So black shirts is just going to be 0. There aren't any black shirts. To have a tan shirt and a brown belt, So tan shirts we're having and having brown belts, there are 3 ways to do that because tan shirts, there are 3 pairs of pants, and then the brown belts, I'm going to have those 3 out of 24 ways with the brown belts. So tan brown belt 1, tan brown belt with the different color of pants. Hold on, let me get this down here. 3 out of 24. Right, so it's going to be black pants, tan belt, tan shirt and brown belts, or red pants, tan shirt and brown belt, or black, tan, and brown. Okay, that's it. So there you go. Hopefully you should be good with the homework. Good luck.